Hi, welcome to Project Geospatial. I'm Adam Simmons, and here with me is Jake Shermeyer from CosmiQ Works. Jake, how about you give us an introduction of who you are, what you do, who CosmiQ Works is, and tell us all about the SpaceNet 6 Challenge.
Sure, awesome. Great to be here, Adam. Thanks so much for having us on. Today I'm going to be talking a lot about the SpaceNet 6 Challenge, which is both a challenge and a data set. My name is Jake Shermeyer. I'm a research scientist at a lab called CosmiQ Works. CosmiQ is a research lab, and it kind of sits at the intersection of machine learning, so some of the newer advanced AI techniques, and geospatial imagery analysis. So we're really interested in finding different objects in imagery and just exploiting overhead collections in a lot of different ways that I can dig into today. My other hat is I'm a challenge manager with SpaceNet. So SpaceNet is a nonprofit LLC partnership between 7 partner organizations this year. It's led by CosmiQ Works, but we've been in existence for a little over 3 years now. We also have Maxar Technologies, Intel AI, AWS, Capella Space, Topcoder, and IEEE GRSS.
Awesome. Well, I think that's an excellent segue into the SpaceNet 6 Challenge itself. Tell us a little bit more how that got started, your involvement in it, and why is it here? Why does it exist?
Sure. So when we founded SpaceNet, there was a lot of data sets really being created for AI and machine learning research. However, there was not a lot of data outwardly available that was permissively licensed for the satellite imagery domain. And what I'm really talking about here is ultra high resolution satellite imagery. So when we first started, we partnered with Maxar, and our goal was to release some really permissively licensed imagery as well as labels. So we focused on a foundational mapping mission now for the past 3 years, with each of the challenges kind of iteratively progressing and issuing out harder problems to our participants that attempt to solve them. So we focused on building footprint extraction. So why would you be interested in building footprints? The primary use case here is really disaster response. So can you identify where all the buildings are in an image? And if you can, that can be really helpful in a disaster response scenario where you might have flooding or other types of activities harming these buildings. We want to be able to track where the buildings are, if they've changed, and what areas are most affected. So part 2 of our foundational mapping challenges has been focused on road networks and routing. We've done 2 challenges that have focused on getting from point A to point B. So not only can you extract the road network, can we also extract a routable network. So what we're talking about here is a vectorized layer. So we want something, not just a pixel mask. We want to be able to get from point A to point B. And SpaceNet 5 focused on actually extracting travel speeds automatically from satellite imagery. So these are the types of challenges we focus on. Now, SpaceNet 6 is one of our more unique challenges in the sense that we're adding in synthetic aperture radar this time. So this is the first time we've had SAR data. So SAR data is a really unique modality. It's common in the remote sensing world, but there's almost no permissively licensed data at the scale that we're working at.
So why focus on SAR data as opposed to EO in the past? Well, tell us a little bit more about how SAR's, why is it starting to become a focus point?
Yeah, well, I mean, there's certainly a lot of new companies coming into the SAR domain that will be releasing new data that's really ultra high res. But the more important aspects of SAR data is that it can penetrate clouds. EO data cannot. And the second aspect of it is it can operate in any illumination setting. So it can operate in the day, at the night. So this means it's a really intriguing technology, especially for disaster response, as I mentioned earlier. If you can see through the clouds, then you can basically constantly monitor what's happening on the surface. Versus with EO data, it's you're going to have some limitations based on the cloud cover that will really render it unusable.
Awesome. So with So it looks like we have a quick question here, and I want to take a brief segue away from this topic of SpaceNet 6 and go into a little bit about your background personally.
Sure.
In terms of your career development for a younger audience. Actually, one individual brought up a question on Twitch here. What is your background and how did you get here? And I think that goes excellent segue into career development, and what route did you take to get where you are today?
Yeah, so I'm a classically trained geographer, I guess you would say. So my background, I went to Penn State. I got my degree in geography. Then I went to George Mason and had a master's degree in geospatial intelligence and geoinformatics. From that, I landed an internship with the U.S. Geological Survey. So I did a ton of work there mapping rainforest changes. I worked in the developing world quite a bit. We were interested in carbon monitoring. So if there's land use change, what is the carbon exchange as a result of that? So I worked in South America, Southeast Asia, and some more work. I've done some work with water and wetland mapping, and then also some agricultural practices mapping in the eastern shore of Maryland. So that was really my first introduction, and with a lot of those projects naturally came exposure to remote sensing, as well as GIS, and more specifically machine learning. So I picked up a ton of machine learning work over my years at the USGS, focused on time series analysis, a lot of different varieties. From there, I ended up coming to CosmiQ just over 2 years ago now, as they have a lot of interesting problems happening in this space, and have been here ever since.
So with the route that you took, what advice would you give someone looking to get involved in the space that you have, either innovative technology integration or machine learning?
Yeah, I mean, I think just having a passion for what you're doing was definitely the most important thing. I really enjoy my job. I don't feel like coming to work every day is a hardship. So you want to actually have something that you're passionate about to kind of set your goals for. I would also say that just kind of choosing the right locations where opportunities might exist for you. So going to school where you could land an internship in the DC area, or maybe the Bay Area where there's a lot of geospatial activity happening. I think that can help you quite a bit, because. So
how about folks who like what you're doing but are a little bit lost in making education route decisions in their education path?
Yeah, I mean, I'm certainly no expert, but I think there are a ton of great open videos and courses online these days where you can kind of test the water and see if you're really interested in these fields, and see if you find them interesting. From there, maybe formal education is your best path. Sometimes for a lot of people, it's not. You can learn just as much online or just by doing hands-on work, I think, versus going to school all these days. So
I appreciate the segue once again in your career background, and a little advice for those who are interested. Back to the SpaceNet 6 challenge. How does someone get involved in the SpaceNet 6 challenge? It hasn't started yet, right? It starts in about another week and a half.
Yeah, so it starts on March 16th. So the challenge will be on Topcoder. So you just go to topcoder.com and search for SpaceNet. You can register there, and that's basically it. You can participate and submit both your code and your scores. So competitors, we asked them. I should explain kind of the whole challenge premise here, which was we have the SAR Collect from Capella Space, so they're one of our newer SpaceNet partners, and we have electro-optical imagery from Maxar. So Maxar's provided imagery over the past 6 challenges now. Our location of interest this time is Rotterdam, the Netherlands. So this is the largest port in Europe. It's certainly an interesting spot. It should be a great spot to test the value of SAR. We will be open sourcing. We've actually already open sourced the data set, so you can go download it right now. It's freely hosted on AWS. All you need is an AWS account. If you go to SpaceNet.ai, you can find all the links for the SpaceNet 6 challenge, as well as all of our previous data sets. And what also goes along with this is we will also open source the code from our top 5 participants. So the top 5 prize winners will have their code released and open sourced so that other people can check it out and hopefully be able to leverage it for some of their problems.
Now I was quickly reading, was there a $50,000 award, or is that across all the certain level of participants?
Yeah, so it's 50,000, and then that's split out. 20,000 will go to the winner, and then it's gradually broken down from there. We also offer prizes for undergraduate and graduate students if you're interested in participating.
Excellent. So what happens? Where do you announce the results? Is that at a special event going forward, or is that a special forum or ceremony? How does that work?
Yeah, so we typically announce all of our results online. So this year, however, we do have a specific tie-in with a venue. So we'll be at CVPR, which is Computer Vision Pattern Recognition. This is one of the biggest AI conferences in the world, at least geared towards computer vision. And we'll be participating in a workshop there called Earth Vision. And we'll be asking some of our winning participants to come there, share their work. And we'll be paying for their travel as well to get them there, as well as their entry fee into the conference. So that's really kind of going to be the showcase. We will announce the winners a little bit prior to CVPR, but it's a cool opportunity for people who are interested in really exploring the computer vision world and that intersection with the geospatial domain.
Great. Do the results from the for the winners or the participants, is that data open source as well? I'm just kind of curious, or how does that work with the submissions? Yeah.
So all of that will be open source. So you could basically retrain or just have use the weights that are shared. So the weights that are spit out of these models that perform the building detection task. All of that is going to be open source as well, and that's hosted on our GitHub page.
Excellent. No, that's great, not just for participants, but also perhaps even educators who want to take advantage of this and the best practices that get put forth. So getting into a slightly different topic, I think SpaceNet 6, once again, incredible challenge. Look forward to seeing the kickoff. But I'm also interested in your personal views on the geospatial industry, where it is now and where it's going. And perhaps maybe from your perspective thus far, working for CosmiQ, what the most innovative technology that you've seen that's really impressed you the most?
Yeah, I mean, at least from an Earth observation perspective, there's a ton of really exciting companies that are launching lots of satellites. I mean, the commercial space industry certainly was kind of walled off for a number of years, in the sense that Maxar, formerly Digital Globe, really had a lot of control over, especially the high resolution EO satellites. I think what's really exciting is there's a lot more domains really coming into play. So players like Capella are starting to launch new sensors, in the SAR domain, and I think that's going to be super interesting. Just seeing how these data sets, these types of data, can really work well with one another and be complementary of one another. And I think that's kind of really what SpaceNet 6 is starting to investigate. How well can EO data be used to help out with the SAR, and what can you actually do with these types of data? And then to the second question, in terms of most interesting technologies, I would say, the computer vision world continues to provide really interesting things that keep coming out of it. I think one of the more interesting things that could really be beneficial, particularly in the geospatial world, would be domain adaptation or image-to-image translation. So if you're not familiar with that, that's basically you might have one image, say it's summer, and now you're going to transform it and make it look like a winter scene. And if you think about this in a geospatial perspective, it could be I have an image in Africa, and now I'm going to try to make it look more like Paris or something, where and if that's your area of interest. Basically, this could be a really interesting pre-processing step.
Is this for the purpose of training data, because it just to standardize images across the board in different scenarios? Is that what you're thinking?
Yeah. I think you could really, right now, one of the major problems with geospatial imagery is you really need labels in your areas of interest. And models typically are not transferable to other locations. So if you can somehow leverage labels and not have to relabel a ton of stuff in your new area and run one of these domain adaptation algorithms up front, I think that could really be a game changer in the geospatial domain.
Nice. That's an interesting perspective, and yeah, I mean, especially with we'll call it inconsistencies and challenges of trying to figure out not just training data, but where to get it. It's and that's a huge challenge for the commercial community as it is right now.
Yeah, absolutely.
What's your perspective of there's a press release regarding an emerging SAR company called PredaSAR. Have you all heard of this one yet?
Yeah. I believe they're based in Virginia, so nearby. But I know there's several other up and coming SAR companies alongside Capella and PredaSAR, Umbra, iSign. So several of these companies coming out now. So I think the real differentiator between these companies is going to be what kind of their maximal resolution can be, how sharp of an image can you actually produce from space, and what's your revisit rates?
And then just purely getting up in the air, right?
Yeah, exactly.
That's the bigger challenge, but it'll be a game changer because these companies that are emerging right now are the first U.S. SAR providers. Traditionally, the SAR satellite sector has been, I would say, monopolized by the Europeans.
Yeah, and that's one of the things that's really exciting as well. We can now actually have this open commercial engagement with U.S.-based SAR companies. When Capella provided this data set as part of SpaceNet, this was really the first time I had ever even seen a half-meter SAR resolution. I've been in this field for about 15 years now. So if you think about that, this can be really impactful to actually start to see these new types of data. And I think that's
now. Do you think
really
a focus on machine learning problems will help drive the economy a little bit different and business models for imagery in general? Traditionally, also imagery has been a little bit too expensive to focus on, training data or even machine learning best practices. Especially, a single image scene can cost thousands of dollars, and that's not necessarily ideal for someone looking for just an image just to start training off of. Correct?
Right. Yeah, and I mean that's why at SpaceNet we've open sourced. We have Rotterdam, the SpaceNet 6. This will be our 11th city, so we have thousands of square kilometers of high resolution imagery available. So I mean, this is going to be a really good starting point for people. It may not be your exact area of interest, maybe it's not your problem of interest, but what you learn from these data sets can certainly be transferable to other problems. And I think we're helping to spark a lot of innovation. At least that's our goal in producing.
That's awesome. One last question for you, Jake, is there's been also an emerging space within, we'll call it commercial RF collection with either Hawkeye 360 or Clio Space. Is there a chance we could be seeing some type of SpaceNet challenge related to those types of sensors in the future?
Yeah, I mean, I think that's something that could be super interesting. I mean, I think we obviously haven't talked with these companies about structuring something like that, but I think in particular, Hawkeye's data would be of great interest to us. Maybe you could pair that with a SAR collect, have RF pings off of boats, something like that. I think it could really add an interesting way to collect training data in the sense that you don't have to manually annotate everything, since you know where things are coming from the RF pings.
Or even some type of hybrid between the imagery collectors and the RF collectors as well. Just that marriage and potential, right? So
yeah, absolutely.
All right. Well, I think. Do you have anything else you want to plug about SpaceNet 6 Challenge, CosmiQ, or anything else?
I'll just show. I can show images of SAR, and that might be just kind of interesting.
Yeah, give me a second here. Let me switch over to that frame. All right, there we go.
So this is part of our training data set here. So this is on our blog. So you go to medium.com, the downlink. So it's THE-the downlink with a Q. So what I'm showing here is a SAR collection. So this is our SAR data that we're working with for the challenge. And you can see that it's quite different than what you might be used to seeing if you're an EO person. We have the building footprints here overlaid in red outlines, but you can see, interestingly, things like boats. You can see how this distortion here, and what's really happening is actually that the waves are bouncing down, hitting the boats, and then something called layover is happening, where the top of the masts here are reflecting back sooner than the boat. The SAR is an active sensor. It shoots the radio wave down, the radio wave bounces back, and that's what's causing this interesting stretching here. So this is something that is going to be, I think, challenging for models really to deal with in the computer vision space, because they're not used to seeing imagery quite like this.
Now, tell me what's going on with the color there, because a lot of us who played with SAR are not used to seeing SAR in color.
Sure, yeah. So we have, so this data set's unique. Just in terms of more data specs, we've got an X-band wavelength here, which is common for a lot of the high-resolution SAR providers, but we're showing it with 3 of the 4 polarizations. So this is a quad-pol data set. So waves can be polarized, they can be given different directionality, and the sensor can both transmit and receive waves in this directionality, either vertical or horizontally. When you add them all up, you can have up to 4 unique combinations. So what we're seeing here is basically backscatter that's kind of reflected off of both horizontal and vertical surfaces. So we've got the HH, VV, and HV polarizations being shown here through the red, green, blue color guns. So that's a lot of technical jargon. SAR can be a bit of a lift to get into, but once you start to understand some of the subtleties and nuances, I think it can be really powerful.
Well, I'd like to give a plug for some of that technical jargon.
Sure.
And that Daniel Hogan, part of your group, I believe, he's recently posted just kind of a lead up to the SpaceNet 6 challenge. You released the SAR 101 Introduction to Synthetic Aperture Radar blog post, correct?
Yeah, SAR 101 and SAR 102 or 201. I think these are arguably the best guides I think I've ever read in terms of introducing people to SAR in a pretty reasonable way. So there's a lot of good explanation there, and I think it transforms the SAR domain into more layman's terms. Obviously you have to have some understanding of what's happening, but I think it's definitely a great place to start if you're interested in learning more about the SAR domain.
No, I have to agree with you. I've been trying to, I've gone through a number of conversations with people over the years, trying to explain the difference between SAR and EO, explain some of the phenomenology, but in an all-encompassing blog post here, Daniel Hogan's managed to put together a great write-up. Yeah. And more than what I could have done in days worth of conversation. So it's nice.
Yeah, and I should give a shout out to our Capella partners on that one. Jason Brown really helped out with that, and we really leaned heavily on the SAR experts at Capella who really know their stuff, and I think it shows with these posts, which is awesome.
Awesome. Well, let's see here. Well, once again, Jake, I don't think I have anything else for you, unless you want to talk about anything else.
No, I mean, I can show some more pretty images here if people are interested.
Well, actually, more imagery is always good to show. Okay. I like showing people examples of SAR that's hard to obtain openly. So right. Just to show examples of what it is and what it can do, I think that's always worth it. So if you want to show some quick examples real quick. I know for those listening to audio, it's tell you what, you'll have to come over to the video set if you want to see some of this goodness.
Yes, yeah, absolutely. Or just check out our blog. Like I said, medium.com /the-downlink with a Q. And you can see all these posts. If you're watching at home here, this GIF is just our EO data in the background, and then we've got the SAR collects coming in. So for this particular collect for Rotterdam for SpaceNet 6, we're working with an aerial platform here. So the platform is just moving back and forth, imaging the ground here. And this platform will closely mimic what the Capella sensor ultimately will be when they launch it in upcoming here very soon, I think. So that's kind of just showing our collection pattern here.
So just to double down on that a little bit, they haven't launched their platform yet. So the imagery that you've gotten from Capella, those are off of the aerial test platform that they use to test their sensor out. Is that correct?
Yes, yeah, exactly. So that their whole purpose in generating these data sets is just to kind of put something out in the open before they actually start getting data off their satellites once it's up in space, and really, testing what's possible. And part of that initiative is with them joining SpaceNet is just getting people more comfortable with SAR. So I think that's been our goal, and trying to help them to achieve that. And hopefully, I think we'll be successful with that.
Now, SAR has a lot of applications, but where do you see it having the most use in the commercial community?
Yeah, I mean, I think there's a lot of, disaster response is certainly our wheelhouse. We'd like to see a huge amount there. I know other applications like, change detection is certainly something that they're interested in with their high revisit capabilities. Beyond that, I think height estimates, so measuring how things change over time. So there's a lot of oil tanks here. Can you measure the height changes of those as they fall and rise based on the amount of oil? I think that's certainly another interesting application.
There's also some talk of having some of these SAR sensors run at night too, correct? So,
Yes.
And that's a huge weakness of EO is even, unless you're running some type of IR sensor, just like VIIRS or something, you're limited to what sensors you can use at night. And SAR is one of those.
Yeah, I think that would definitely be very interesting if people, if companies start launching these sensors, if they can operate both in sun synchronous orbits, or also something where you might have a nighttime orbit to maybe image things and see what's happening, and what really changes over time at night, because it might be quite different.
Awesome. All right. Anything else to show here?
I think that's probably about it. Just some comparisons of SAR versus EO versus false color composite imagery. So again, point everybody to our blog, but I think we can.
Will do. And actually, if you can do me a favor and send me the URL for this blog post,
Sure.
I want to grab it and put it in the show notes. This is a great resource. I grabbed, once again, the SAR 101 and 201 blog posts as well. And that'll be posted on our In Construction Education page that we're creating at the moment, which is going to have tons of resources, including open sources on natural disasters, open data catalog of hundreds of data sources we've collected over the years, and as well as any kind of educational videos folks are interested in the geospatial industry overall. Even the geospatial revolution stuff that Penn State shot almost 10 years ago. And they've announced that they could be working on another follow-up to that series here soon. So look forward to that.
Awesome.
Well, appreciate your time, Jake. And once again, for those who are interested, this is the recording of this will be on Twitch, but a more edited copy of this will be on YouTube, and all the audio versions of this segment will be on the podcasting platforms, Google Podcasts, Spotify, Apple Podcast, Radio Public, anything you can think of, you're likely to find us. And you can, of course, look on our website. And look forward to seeing what's going on with the SpaceNet 6 Challenge, who wins it, of course, and what interesting projects come out of it. So once again, I'm Adam Simmons here with Jake Shermeyer from CosmiQ. Thank you for joining us.
All right.